Okay, this video is about vertical asymptotes. So I'm going to talk about two functions that have vertical asymptotes, so f and g. So let's first start with f, and I'm interested in the limit as x goes to 0 for this part, for f. So before we do anything, let's kind of think about this function. The numerator is 1, right? So it's a rational function. The numerator is 1, so that doesn't change. And then the denominator is x squared. So x squared, first of all, the function's not defined at 0, right? If I plug in x equals 0, I get something undefined, so 0 is not in the domain of this function. Now, if I plug in anything else, then x squared is positive. If I take a non-zero number and I square it, I get something positive, right? If it's positive and I square it, it's positive. If it's negative and I square it, then it's positive. So this function is going to be 1 divided by a positive number, right? So that means this function is always positive. So the range of this function is above the x-axis. So like I'm only going to see y values above the x-axis here. So we don't have to worry about sign for this problem, like positive versus negative. So this function is always positive. So now let's think about what's happening as x goes to 0. So as x goes to 0, the numerator is always 1. When x goes to 0, the denominator is getting very small, very close to 0. So I'm taking 1 and I'm dividing it by a number that's very close to 0. And so if I think about like 1 divided by 1 over 100, that's 100. If I think about 1 divided by 1 over 1,000, that's 1,000. And as the denominator gets smaller and smaller, the whole fraction is going to get gigantic, right? So it's going to sort of blow up. So we might think that this function, basically it can get as large as I want. It gets arbitrarily large. So let's kind of look at what the function looks like. And the graph is showing us that. So as x goes to 0, the function is blowing up. There's a vertical asymptote here. The function is tending to infinity as x goes to 0. So it's getting arbitrarily large. So this limit is infinity. Okay, now for the next one, it's slightly more complicated. So I want to think about this function g of x, and now I want to think about the limit as x approaches 3. And the complicated part is now we have to worry about the sign of this function. So before, with f, everything was positive. Here, that's not the case. So the numerator is positive. If I plug in, let's say x equals 0 here, then it'll be 1 over a negative number, right? So anytime the denominator is negative, the whole fraction is going to be negative. So that means anytime that x is less than 3, then the denominator is going to be negative, right? Anytime x is less than 3, then x minus 3 is less than 0. And so this is negative. The function's not defined at x equals 3, because I would be dividing by 0. And if x is bigger than 3, then the denominator will be positive, right? If x minus 3 will be bigger than 0, and so the whole fraction will be positive. So we have this thing where, let me graph the line y equals 3 here. Oh, sorry, x equals 3 here. So if we look to the left of this line, my function is going to be negative. And if we look to the right of this line, my function is going to be positive. And if we think about what's happening, it's besides the sign of this, the positive versus negative, it's sort of the same thing as the last time. So I'm taking, as x goes to 3, I'm taking 1, I'm dividing it by a number that's very close to 0. So this number is going to get very large, but when I say very large, it means in absolute value. Okay, so if I divide by a number that's very close to 0, but it's negative, then the absolute value of this number is going to get very large, but it's going to be a negative number, right? So on the left-hand side here, this function is going to approach, it's going to get very, very negative. So it's going to approach negative infinity. Whereas on the right-hand side here, this function is going to be very, very positive. So the right-handed limit is going to approach infinity. So we have this thing where the left-handed limit is going to be negative infinity and the right-handed limit is going to be infinity. So in that case, we say the limit doesn't exist. Or, I mean, actually saying the limit is infinity is saying it doesn't exist in a very particular way. But for this case, it's really saying it doesn't exist because the left and the right sides are not doing the same thing. So let's look at this thing and just make sure that what we said is correct. And so the graph looks like that's what's happening. And so there are kind of these, like, when you have a vertical asymptote, you have to be very careful about the sign. Generally, a vertical asymptote is happening because you're dividing by zero. That's kind of the way that I can get a function to blow up to infinity. And so if you're dividing by something very close to zero, the thing about zero is that numbers very close to zero can be either positive or negative. If I just say I have a number that's really, really close to zero, I don't know if it's positive or negative. And so generally what's happening is I'm dividing by something that potentially could be changing sign. And so we have to worry about whether the function is positive or negative. It's very important. So generally there are these two types of vertical asymptotes, where where the function is kind of positive on both sides or negative on both sides, and then another type of vertical asymptote where the kind of the sign changes on either side of the vertical asymptote.